Okay, we talked about these steps. We're going to show the statement is true for n equals 1. We will assume the statement is true for n equals k, and then show the statement is true for n equals k plus 1. So those were the steps for mathematical induction. And so what we're going to now do is go ahead and look at a second example, because if you remember, we looked at this example first. We're going to now look at this next example here. So if you want to go ahead and get that written down, we'll go ahead and go through the different steps. If you remember, there were 2 steps we needed to do. Okay.
This is proving by mathematical induction.
This is proving by mathematical induction. This is the same thing we did yesterday. We're just going to go ahead and add 2 problems onto that.
Is this one in the book?
I don't know.
Okay.
So if you remember, we broke this down into 2 steps. The very first step is to show the statement is true for n equals 1. So I'm going to plug in 1 wherever I see n. And so if you notice here, I see an n here. So I'm going to show that 1 squared equals, and then on the right side, wherever you see an n, you're plugging a 1. So you've got 1, 1 plus 1, 2 plus 1, all over 6. So let's figure that out. And I know I'm going to be using a lot of room, so I'm actually going to go horizontal on this. You might want to go vertical on your page. But on the left side, I know that 1 squared equals what? 1. On the right side, let's see, I have 1, I have 2, I have 3. So 1 times 2 times 3 is what? 6 divided by 6 is... Now remember, okay, it might not always equal 1. It might equal 2, it might equal 4. But you just have to show that that's a true statement. So now my second step is assume the statement is true for n equals k. So basically what I'm going to do is duplicate the very first step, except for in place of n, what am I going to put? K. So I've got 1 plus 4 plus 9 plus k squared, and that's going to equal k times k plus 1 times 2k plus 1 all over 6. What is my next step to do? You need to put k plus 1. So basically, I rewrite the whole step right here. And then remember, I add one more additional term. Okay? So I rewrite exactly what's in blue, except for I'm going to go one more term. I'm going to go k plus 1. Over here on the right, remember, wherever you see k, what are you putting in? K plus 1. So that'll equal k plus 1. Then my parentheses, k plus 1 plus 1. And then my parentheses again, 2 times k plus 1 plus 1, all over 6. So wherever you see k in the blue, you're replacing it with k plus 1.
And is it k squared on that side?
Yes.
Is okay.
So now if you remember, our whole goal now is to get left to equal right. Does anybody remember what our trick was now on the left side?
So everything up to the k plus 1.
Everything up to the k plus 1 squared. What does this equivalent to?
To the top is
Yep, it's equivalent to what's here in blue. So I'm going to plug in k times k plus 1 times 2k plus 1 all over 6. Okay, so I have k plus 1 outside. Inside I've got k plus 2. What will this simplify to be here? 3. Good. All over 6. The other thing, I'm going to go ahead and put parentheses around the k plus 1. Okay. Now, what I'm going to do now is I'm going to go ahead and FOIL out this. All right? And I'm also going to start to FOIL out this. I know that this is k squared plus k. Okay, so I end up having k squared plus k times 2k plus 1. All of that is over 6, plus, what does k plus 1 squared come out to be? That's going to equal here on the right k plus 1 times k plus 2 times 2k plus 3 all over 6. What are you going to do now? What do you think? Let's get rid of something. Let's get rid of the 6's. Yep, get rid of the denominator. So I'm going to multiply this by 6. I'm going to multiply this by 6. That by 6. That by 6. That by 6. Okay. So on the left side, let's simplify this even a little bit more. Let's FOIL this out. Okay, so when I FOIL that out, what do I get? 2k cubed plus 2k squared plus k. This is going to be 6k squared plus 12k plus 6.
You said times the first one's like 6.
No, but you see, the thing is, those cancel. See, that's the whole purpose of doing that, is because then they cancel out, and then you're gone with the 6. And so really the only thing the 6 affects is these 3 terms here. Okay? Now here, what I'm going to have to do here is I'm going to go ahead and FOIL out the first 2, and then I will take that times the 2k plus 3. So to start by FOILing this out, I'm going to do this. So I get k squared plus 2k plus 1k plus 2. So it'll be k squared plus 3k, oops, not squared, plus 2. And I'm going to take that times 2k plus 3. My next step on the left side, what do you think I'm going to do? Combine like terms. So I get 2k cubed. What else do you get? 9k squared. What else do you get? What else do you get? Good. So now I'm going to do the same thing over here on the right, except for I've got to FOIL that out again. So yeah, big mess. Okay, so I start with k squared times 2k, which is 2k cubed. Then I do k squared times 3, which is 3k squared. Then I do 3k times 2k, which is 6k squared. Then I do 3k times 3, which is 9k. I do 2 times 2k, which is 4k. And then I do 2 times 3, which is 6. Do I get the exact same thing? Yep, so we're good. So, final step is you need to make sure that you write them so they're the exact same. I will tell you right now that this is one of the more difficult ones because it deals with a fraction. Okay, they aren't going to be this difficult come test time. Okay, so anyway. So let's go ahead and look at another example here. Right? So, 1 plus 4 plus 7 plus dot 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 plus 3n minus 2 equals n over 2 times 3n minus 1. So we've got 2 steps. Okay? Now this one shouldn't be as bad as the one that we just got done doing. It should be a little bit easier. That one that we did in the middle was probably the toughest one of the 3 we're looking at today. So what are we going to do here? Substitute in 1 for n. So tell me what that's going to look like here.
3 minus 2.
3 times 1 minus 2 equals 1 over 2 times 3 times 1 minus 1. So what is 3 times 1 minus 2? Okay. 3 times 1 minus 1 here is 2. So what's 1/2 of 2? Done. Okay, so every time you should be able to handle that. If you don't get anything else from here, you should be able to handle that step.
Is the second half of our task going to be like a large majority?
No. Probably 1 or 2 problems tops. So my next statement, remember, is my assumption statement. I'm assuming that this is true. So remember, I'm going to go ahead and put in k in place of n. That's all you're going to do. Right, so I'm going to go ahead and plug in k plus 1. So I'm going to go ahead and duplicate this step right here, And then what I'm going to go ahead and do is do a plus 3 times k plus 1 minus 2. On the right side, k plus 1 over 2, very good. And then parentheses, 3 times k plus 1 minus 1.
Well, you know that first part
Okay, so as you've said, this whole first part here equals k over 2 times 3k minus 1. This, let's simplify this a little bit. If I distribute, I end up getting 3k plus 3 minus 2, which is what? 3k plus 1, good. Oh, gotta write a 1, not a 2. Okay, so outside I've got a k plus 1 over 2. What do I have inside? 3k what? Plus 2. What causes the problems? The fractions, so we're going to get rid of them. What are we going to multiply by?
2.
So I'm going to multiply this by 2. Now notice, this here is one term. Okay? The next thing I multiply by 2 is here, here, here. Okay? So now, on the left side here, those 2's cancel, and all that's going to leave me with is k times 3k minus 1. What do you get next? What do you get next? 2. On the right side here, those 2 cancel. That leaves me with k plus 1. So the final thing I need to do now is just simplify on the left and the right. So let's distribute the k to each. Distribute the k, you get 3k squared minus k plus 6k plus 2. On the right side here, what do I get? 3k squared plus 2k plus 3k plus 2, which, yeah, it'll equal to 5k, you're right. What do you notice what each of them equal on the left side and the right side? Good. And they match, which is exactly what we wanted to have happen. And there you go.
How often are these not
They always will.
met?
They always will work.
Like in a homework?
Yes, you will never ever not be able to do it. And so the biggest key for you is if you get to this pink step and you find they don't match, you've got to somehow figure out where you went wrong. So this is kind of like an essay problem when I grade it on your test, because I actually do go through your steps. Okay, I go through your steps on these. So you have 4 problems today that you need to do. Remember, I gave you the assignment yesterday. Your assignment is found on page 625. It's to do 1, 2, 4, and 5.